Hello and welcome to MCS Tutoring, your source for premier TI-84 plus CE and TI-84 plus CE Python calculator programs. We're going to be doing a student's worksheet she sent in. This is awesome. She has 3 questions. I want to show you the gas laws program. So to get to that, let me show you. We're going to press PRGM on the calculator keypad in the upper middle section. If you have a Python calculator, it gives you this. Otherwise, it's just going to go to TI-84 basic programs, or TI basic, sorry. We're going to choose that. And then we're going to do Gas Laws 5, which is the most recent rendition of the Gas Laws program. And you have to press enter twice, once to select it, another time to run it. So that is a little point of confusion for people. But don't be worried. Okay. Now, you also have to figure out a few things like which menu item you're going to be using. So this first thing, this gaseous mixture made from 12.36 grams of O2, 11.31 grams of CH4, and 13.56 grams of CO2 is placed in an 11.49 liter vessel at 3.1 degrees Celsius. What is the total pressure in ATM atmospheres in the vessel? Recall PV equals nRT. That's the ideal gas law, by the way. The gas constant R, okay, so they're giving us the R. There's actually a few renditions of R. And it's giving us Kelvin, and then the atmosphere is 760 torricelli's. So look, one thing, God, this is going to sound like clickbait. One thing they don't want you to know is Torr, like the number of torricelli's, is the same thing as, oops, I can't even spell the letter M. It's the same thing as millimeters of mercury. This is the same thing, torricelli's and millimeters of mercury, same thing. So just a heads up there. So what we're going to do is, this is going to be, I think it's like partial pressures or combined pressures. So this is actually in the more menu. This isn't one of the main things we typically look at. This is mixed gas pressure. So look, few things. And I really do recommend that you annotate just as I am right here. It looks like how many gases? Well, it's like 1, 2, 3. And I'm not kidding. I'm going to number these so I know which one's referring to what. So this can handle between 2 and 4 mixed gases. We're going to choose 3 for this option here. And then what is the mass of gas 1? Well, that's 12.36. Now, look, this is what I'm not entirely in love with science, especially chem. There's always these conversions. They're pesky, okay? So we need to find the molar mass of this O2. So let me go over here and move over a little bit. So O2, and you do need, unless you have like a really good memory, you're going to need a periodic table. So O2, that means 2 times O. And let me explain what that means. Because that subscript 2 is where I'm getting this 2 from. So it's 2 times, and you have to look at the molar mass of oxygen. That's 15.9994, I think. I'm just going to say 2 times 16, which I don't need a calculator to do this. I know that's 32. So that first one, that molar mass is 32. And look, if I didn't know it was 32, you could actually do the math within the enter part, like equals what? 2 times 16 and enter. Now, yeah, see, this is the pesky part with chemistry. You got to go back. What is the mass of the second thing, the second gas? It's 11.31. And look, be careful. And I'm saying this not to finger wag at you. I'm talking to my younger self. I was totally cavalier about entering stuff in my calculator. That's why I probably didn't get straight A's in science. I'd gotten A minus and B now and again. Whatever. Even worse, who knows? So the molar mass, CH4, which I think is methane. So look, CH4, what does that mean? It's going to be 1 times C, which is, I don't even know what that is, and 4 times H, okay? So look, you got to look at C, right? Carbon, 12.011. So I'm just going to go 2 decimal places, so that's 12.01 for that. And the 4 times H is 4 times, and then hydrogen is way up in the upper left. It's 1.0079. I'm going to go 1.01. So I'm going to go 1.01. So I'm just going to basically add these two together. I'm going to box them. So we're going to add these two numbers. So look, the molar mass, and again, we could just do the math right here. 1 times 12.01 plus 4 times 1.01 for that H4. And then We got to go to the third gas. So I'm going to go back here. Sorry, I'm keep scrolling all over the place. Just be patient too. And I guess I'm taking these nice and slow because I tend to get these wrong if I go quickly. The mass is 13.56. The molar mass, okay, that's where we got to go here again. And look, comment if you would like me to have a molar mass converter within the gas laws. I have it within the Chem Solver program, but not within the gas laws. I might actually include that. I think that might help a lot. And I do have a unit converter, which we're going to be using in question 2. Oh my goodness, yes. Okay, so look, getting back to this. This is going to be 1 times C, which I know is 1 times 12.01, because I remember, hey, we got the information up here. And this is going to be 2 times O. And again, why is it the 2? It's because that subscript refers to that. So that subscript 4 for this H referred to 4 H's. So look, this is going to be 2 times, and I think it was 16. So we're going to add these two things here. So the molar mass is 1 times, and I'm being paranoid. I know you could just enter 12.01 rather than 1 times 12.01. And then plus that 2 times 16. And then what's the volume? Now look, again, pesky thing about science, right? Or chem specifically. You've got to make sure you get your units and everything right. So this 11.49 liters, that's my volume. 11.49. Now look, here's the cool thing. I converted the temperature to Celsius. If you would like an option to have it in Celsius or Kelvin, let me know in the comments. I can probably add that to it within a week or two. But since this student's homework was temperature in Celsius, I'm going to put, I made the program for its temperature in Celsius. So 3.1. I know chemistry teachers all over are pulling their hair out. They're like, no, it should be Kelvin. It's like, dude, I got it converted. We're all cool. Now, look, again, I talked about the 3 different R's. I'm not kidding. This is what smoked me in chemistry. I didn't know there were 3 R's until I got a nasty grade on a test. I'm like, what? Okay, so I wasn't paying attention. I want you guys to pay attention. So it is the 0.08206. That's the most common one, typically like an AP Chem or college chemistry. So that's why it's the first option there. So look, it's 2.76 ATM atmospheres. And again, if your teacher asked torcellis or millimeters of mercury or something like that, you can convert it. But I just wanted to check, and 2.76 ATM is the correct answer. Thank goodness we got that one right. Okay, cool. So that is kind of a pain in the butt because you got to do all these conversions, but that's just the reality of it. Because you think, oh, 3 questions, cake. No, chemistry, never cake. Same with physics. Everybody's like, oh, it's cake. It's like, nah, they get a little more complicated. Ammonium nitrate, NH4NO2, decomposes upon heating to form N2, which is nitrogen gas, according to the following balanced chemical reaction. When a sample of NH4NO2 was decomposed in a test tube, 728.1 milliliters of N2 gas, that's a volume, by the way, was collected at 29.49 Celsius. That's a temperature, by the way. And the total pressure was 764.1 torr. That is pressure here. Recall PV equals nRT, so we're probably going to be using that ideal gas law. The gas constant R, okay, we got the R here. So we got P, V, R, and T. How many grams of N2 were collected? So here's the nasty thing, right? We're going to be able to find the number of moles, and then we've got to convert to grams. So we have to do a conversion outside of all this. Actually, we have to do conversions inside of this as well. So look, I'm just going to go back and exit this for a second. And I'm going to go to the unit conversion program just to help you out. You could do this by hand. Look, a lot of you guys are great at doing unit conversions by hand. So just fast forward a couple minutes. But first thing, we've got this volume, this nasty volume thing. We need the volume. By the way, it's going to ask us the volume in liters. So we've got it, and I'll put the red is going to be what we need. So the volume in liters. Okay. So first we're going to convert this volume. It's milliliters to liters. That's the conversion we need. Number 2. So the milliliters is 728.1. We're like, okay, cool. It's 0.7281 liters. So 0.7281 7281. Sorry for my cramped writing there. At 29. And look, I do know that for PV equals nRT, the temperature does have to be in kelvins. So it's something kelvins. So we got to do that too. So look, we're got to go back to the main menu, and we're going to do temperature. And we're like, oh, what do we want to do? We want to do Celsius to Kelvin, C to K, option 3. So what's the Celsius? It's 29.49 Celsius. Okay, cool. It's 302.64 Kelvin. And typically that's where your ranges are going to be, like between 250 to 350 Kelvin when you actually do a lot of these problems. I mean, just generally speaking, not every single case. Oh, then we got to do pressure. Oh my gosh. So, pressure, we're going to do the more menu. We're going to do pressure. And by the way, I don't have Torricelli's directly to ATM, but I do have millimeters of mercury to HTM. So look, remember this note here. Torricelli's is the same. Torr is the same as millimeters of mercury. So we're going to go pressure is in ATM. Oops. I think it's an ATM, right? So we're going to go millimeters of mercury to ATM is option 6. We've got 764. So it looks like it's 1.005 ATM. Okay. And I know I'm breaking all kinds of rules with significant figures. Please forgive me. And then we have the R. The R we already know is 0.08206. It's kind of given. It's like blah, blah, blah. So I'm just going to go like that. Okay, I know. So we're going to go back to the programs, TI Basic, and then we're going to go to the gas laws. I had to press like the 2, or I could have pressed enter to select it, another enter to run it. Ideal gas law, number 1. PV equals nRT. What do we want to solve for? We're going to solve for N, which is number of moles, by the way, if you're not familiar. We're going to use that R value is 0.08206 liters atmosphere per mole Kelvin. It's option 1 there. And it asks us a bunch of questions. And it gives us like, hey, heads up, by the way, P is in ATMs. So, okay, P is 1.005. So look, again, do not be cavalier about units. Make sure you're converting everything to the right units. So we've got ATMs. Volume is in liters, by the way. So that's 0.7281. And temperature's in Kelvin. So 302.64 Kelvin. So look, we've got the number of moles. So that's not even the answer we actually need in the end. But so I've got the number of moles of mercury is 0.029464512. Okay. Now here's the trick. For mercury, we want to know how many grams. So look, the molar mass of mercury, we got to go, or molar mass of mercury, what am I doing? Molar mass of nitrogen. It's nitrogen. So look, the N2, what does that mean? That means it's 2 times N, which is going to be 2 times, and we have to look this up. 14, I'm going to go 14.00674. I'm actually going to go all the way, 14.00674, I believe it was. Okay, so look, I'm going to get out of here for a second. I'm going to exit. And just to find out what the molar mass of N2 gas is, because it's 2 times the molar mass of nitrogen. So I get 28.01348. And if I did the units, I'm just going to move this over for a second to help you guys out. That's, dude, it's not right. That's grams per mole. Now look, we want grams, which is cool. That's the thing on top. So I'm going to take this number again. 0.029. I know, probably my next iteration of the gas laws program will already do this. But I just want to put that in my calculator for a second. Because what we're going to do is multiply them by number of moles, the 0.029 moles. And look, here's the cool thing. When converting units, if you have to do it by hand, this is like saying over 1. And then you kind of cross cancel this way. So I'm just going to multiply that, this 0.0029, yada, 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 times that number up here. Instead of having to type it again, you can actually use the arrow key. That's super handy on this calculator. And press enter. So it entered that number for you. And then enter again. And I get 0.8254. Okay, now here's the thing. I think the answer is 0.0824. I'm going to say close enough. I'm probably actually close enough to get that right. So that's, and in grams, and then look, here's me getting points off. I didn't write grams into. And then what was that first one? ATM, like I could write pressure equals. You look, writing more stuff is better in chemistry. I tend to be more of a minimalist math guy, but man, you got to label stuff in chemistry big time. So I'm just telling you that. Okay, we go on. I know this has been a marathon, even though it's only like 3 questions here. Go back to the gas laws. Okay, this one, thank goodness I can enter just straight numbers here. So this is, we're calculating the VMS. It's something about the, I don't know. I don't even remember, man, the RMS velocity. Root mean square velocity. Goodness gracious. Here's the actual formula here. Rad 3RT over M, which is just the same thing as this guy right here. Now, what is the molar mass? So cool. Molar mass, 71.8. So I'm going to enter that right there, 71.8. What's the temperature? Now look, it's asking it, it's giving to me in C. Typically, a lot of classes it's going to be Kelvin or C that you have to convert to Kelvin. But hey, that's okay. I'm asking in C, so put it in C here. Again, put in comments of like, hey, I'd rather have the option to put it in K or the option to do either. I can probably accommodate that within a week if you just comment that on a YouTube video here. Okay, temperature's there. And then look, we've got it, man. This is great. It's 324.556 meters per second. Now, this is what's cool. It does all the conversions for you behind the scenes, and we got the right answer, 325 meters per second. Oh my goodness. So look, if this has helped you, like it. If it hasn't, dislike it. That's okay. Give me a reason though. Why, how this thing can be improved. Because right now, half of the innovation of the TI-84 plus CE calculator programs is driven by YouTube comments and customers contacting me like, hey man, could you add a, what was that thing again? What was that called? I'm not even kidding. Could you add the root mean square velocity for this homework that the student started like about a week ago? I'm like, heck yeah, just give me time. So look, that's cool. And again, you get 30% off calculator programs if you subscribe to the email list. Don't worry, I don't over spam you. Maybe the first week you get like 3 or 4 emails. After that, it's like at most typically like once a week, unless there's some major sale going on. But you do get discount codes, between 10 to 30% now and again. And look, hope everything works well for you in Chem, and I'll catch you next time.